Alright, this is our third review about exponential and log functions. This is only part one of the review, so watch out for part two, which will be the homework. If you have a pencil in your hand, put it down. Learn how to do it, but then go back and do it by yourself. Alright, so this one is a compound interest problem. So the first thing is to decide which one of those formulas we're going to use. You will not be given the formulas. Now, the two choices are, alright, are we going to use this formula or do we use this formula? Well, this is the one we use when we know how many times a year we are compounding or collecting interest. For example, semi-annually, n would be 2, twice a year. Quarterly, n would be 4 times a year. Monthly, n would be 12. Daily, n would be 365. On the other hand, if they don't give us a certain number of times a year, but instead they say we're just going to compound continuously, meaning all the time, then that's when we use this formula that doesn't have any n in it. E is a constant, approximately 2.72. So this first one, part A, says continuously, so we will definitely use this PERT formula. So we're going to start off thinking this, y equals p times e to the RT power. Now this 9,000, if it's the initial amount, it goes here for p. If it's the amount we will have years later, it will go here for y. You deposit 9,000 in an account that earns this much interest. Find the balance 8 years later. So 9,000 is your amount now, so it will go here for p. So I'm going to have y is equal to 9,000. Then I've got e to the RT power, so 0.078. Alright, times 8, because it says 8 years, so that'll be my time. Okay, on the test you will not be allowed to use your TI-30XS multi-view, so what you will do is you'll put a box around this, and that will be your final answer. Alright, but for now we will go ahead and actually use the calculator. So 9,000. Then I need the e, so I do second natural log to get the e. 0.078 times 8. Okay, so our $9,000 8 years later will become $16,797. Oh wait, that's a comma. And 41 cents. Alright, similarly for this one, we're going to need the other formula. It's not continuous. Alright, so we're going to be using this formula. So I'm going to go ahead and copy down the formula itself first. So that is y equals p times 1 plus r over n to the nt power. Okay, quarterly, so that means n equals 4. Alright, so here we go. So that'll be y equals 9,000 times 1 plus 0.078 over 4 to the 4 times 8 power. N and t. T is still 8 years. So again, on the test, you would just write this down for your answer. But we will go ahead and do it since we have the calculator. So 9,000, 1 plus 0.078 over 4 to the 4 times 8 power. Okay, so that's 16,696. Uh, 0.82. All right, notice we always get a little bit more money when we compound continuously as opposed to quarterly or daily or anything like that. Number two. Number two, write a log function that has been reflected over the x-axis. Well, let's just get started. All right, let's start with a good parent function, which would be like log x. If it's going to be reflected over the x-axis, that means there'll be a minus in front of it. And then if it's going to have a vertical asymptote of x equals 4, now look guys, we know that usually the asymptote is right here, okay, on the y-axis. So if suddenly we're having the asymptote that's at, what did it say, x equals 4? Okay, that means the asymptote is over here. All right, that means that asymptote has moved 4 spaces to the right. That means the whole graph must be moving to the right. So, what kind of change causes you to move to the right? Well, that's an inside of the parentheses change. And remember, it's the opposite of what you would normally think. So a minus 4 will actually be a shift to the right 4. So that will give us the asymptote of x equals 4. So that would be your answer for number 2. Number 3, still writing a log function. So again, let's start with the parent function. F of x equals log x. Let's see, we need it to be shifted down by 5 units. So just put a minus 5 on that. All right, just make sure you don't use any parentheses. If I put parentheses in, then this becomes to the right 5. But without the parentheses, then this minus 5 is like stuck on the end. It's like this. All right, it's assumed to be outside of the parentheses. So then this becomes a shift of down 5 like we want it. Okay, and vertically stretched by a factor of 2. Well, vertical stretch is when you multiply the function by 2. So that would be your answer to number 3. Graph each function using a table of values. Okay, you should be graphing 2 graphs, but the first one we're just going to use dots only. As you know, for log functions, we start with the y values, and we go -2, -1, 0, 1, and 2. And then we will find the x values. Now, to do that, it's useful to look at the parent function. So the parent function is y equals log base 1/3 of x. That's the parent function. Now, if I rewrite this in exponent form, so I will start with the base, like I always do, and then the x and y are going to change sides. So we'll have x over there, and y will be over here as an exponent. So I can use this to find all my x's now. So 1/3 to the y power means I'll be doing 1/3 to the -2 power, and 1/3 to the -1 power, 1/3 to the 0 power, 1/3 to the 1 power, and 1/3 to the 2nd power. Remember that if you do a negative power on a fraction, it becomes the reciprocal. So this would turn into like 3 to the +2 power. The reciprocal of 1/3 is 3. But 3 squared is 9, so that's why we will just have 9. Alright, again, negative makes this reciprocal, so it'll be 3. Anything to the 0 power is 1. To the 1 power, I will just have 1/3. If I square it, it'll be 1/9. So these are the x values and these are the y values. Is there an a value that I need to do? Sure, there's my a value right there. So to get from the y values to the new y values, I need to multiply everything by 2. So this will become -4 and -2 and 0 and 2 and 4. Alright, once you have the new y values, you can cross out the old ones. Now we haven't done the shift yet, this +6, so whatever dots I graph next will be temporary, and so I like to do those in green. Okay, so 9, -4. Okay, so 9, comma, -4 would be right here. 3, -2 will be here. 1, 0. 1/3, 2. So just a little bit over and up 2. 1/9 is so close to 0, it's practically 0. So 1/9, comma 4 is going to appear to be on the line, but up 4. So these are the 5 points we would start with, but we will not draw the curve because they are temporary. But now we'll do the shift for the final answer. Now this +6 means that we're going to be moving left 6. Okay, and that's the only shift, alright? So left 6, I'll take each one of these points and move left 6. Okay, so that'll be here, and then this will be here. Okay, 1, 2, 3, 4, 5, 6. Okay, I've moved every single point left 6. So these blue points are the real points that I'm about to graph. Okay. So we'll need the asymptote. Since we're moving left 6, that means the asymptote is also going to be left 6. Alright, so there's the asymptote, and we can see that the curve is getting closer and closer to it. So by the time it gets up here, it is going to appear to trace the asymptote. Okay, something like that. Okay, please make sure your graph goes all the way to the edges of your grid. And that's it. So that's the end of number 5. Number 6, same type of thing. So we start with -2, -1, 0, 1, and 2. The parent function here is y equals log base 2 of x. So in exponent form, you start with the base of 2. The y and the x change sides. So I'm going to have x equals 2 to the y power. So that means I can find these x's by doing 2 to the y power. So 2 to the -2, 2 to the -1, 2 to the 0, 2 to the 1, and 2 squared. Well, a -2 is going to drop you down to the denominator, so this will be 1/4. This will drop down as well and be 1/2. Anything to the 0 power is 1, 2 to the 1 power is 2, and 2 squared is 4. Now, do we have an a value? This problem does not have an a value, or a value is 1, you could say. Either way, we will not be needing the third column. So, still, as I graph these points, they are temporary because we have not done the shifting yet. 1/4 comma negative 2. So that's over a little bit and then down 2. And then 1/2 is negative 1. So here's half of a square over and down 1. 1 comma 0, 2 comma 1, and 4 comma 2. So here are those original points. But now we have to shift them. So because of the -1, that's going to be a shift to the right 1. All right, and because of the -3, that will be a translation down 3. So right 1 and down 3 for all of these points. Okay, so if I go right 1 and down 3, it'll be here. All right, the next one will be here, and here, and here, and here. So these are the final points, so we will graph and connect them. First, the asymptote. Because the graph is shifted to the right by 1, that is going to affect the asymptote. So you can see that the graph will be approaching this asymptote, and by the time we get down here, it's going to appear to trace the asymptote, even though in our minds we know that it never really touches. Alright, please make sure your graph goes all the way to the edges of your grid. So that's it. That's the final answer for number 6. You must show the asymptote. That is not optional. And you must show your original points, your unshifted 5 dots. Please don't connect them. For number 7, we're supposed to fill in this information for number 5. Okay, so here's number 5. So the domain, that's left to right. So that's -6 to infinity. The range is bottom to top in that order. So this goes down forever and up forever. So that's -infinity to +infinity. The asymptote, of course, is x equals -6, our vertical line. Do not forget the x. It has to be x equals -6, not just -6. And increasing or decreasing is read from left to right. So as I travel from left to right, you will also find that you are going down, 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 down. So that graph is decreasing. All right, number 8, finding the inverse. To find the inverse, you have to switch x and y and then solve for y. So please understand that this is like having y equals log base 8 of x plus 5. So when I switch the x and the y, I'm going to have x equals log base 8 of y plus 5. So now I can rewrite this in exponent form, all right? My goal is to get y by itself. Always start with the base. In exponent form, there's my base, and then the x and the y plus 5 will trade sides. So the y plus 5 will end up over here, and the x will end up as the exponent. So getting the y by itself just means we need to subtract y from both sides. And this is going to basically be the final answer, but I will put the f back in. Just put a little -1 for inverse. So f inverse is equal to 8 to the x power minus 5. All right, number 9. Again, this is like having y equals all this. Switch x and y as your first step. So this becomes x equals 3 times 6 to the y power minus 5. Notice that finding the inverse involves changing form. So if you start off in log form, you're going to end up in exponent form. If you start off in exponent form, you can bet we're going to end up in log form. By the way, if you have a pencil in your hand, put it down. Watch the video, learn how to do it, but then see if you can go back and do it yourself. Anyway, if I want to get this y by itself, before I can put it in log form, first I need the base and power to be by itself. So let's start by adding the 5 to both sides. Okay, so that'll give us x plus 5 is equal to 3 times 6 to the y power. Still got to get rid of this 3, so let's divide both sides by 3 like this. Okay, so that's going to give us x plus 5 over 3 is equal to 6 to the y power. Now that I have this base and power by itself, I can go ahead and rewrite this in log form. It's already in exponent form. So let's start with the base of 6. In log form, of course, you're going to have log. So log base 6 for sure. Now, the rest of it will switch sides of the equation. So the y is going to come over to the left, and the fraction will come over to the right. So that's why I will have y equals log base 6 of x plus 5 over 3. And that's the answer, but let's just get the g to the negative 1 power, well, that's, the g inverse notation back in there. So we'll have g inverse, and that is truly your final answer. Alright, once again, this is like having y equals. And our first job is to switch the x and the y. So we will have x equals natural log y minus 7 plus 3. Before we can rewrite this in exponent form, we need to get the log expression by itself. So we need to do minus 3 on both sides. So that's going to give us x minus 3 is equal to natural log y minus 7. So now I can rewrite this in exponent form. Please understand that there is an invisible base e that you're using anytime you deal with natural log. So we need to start with that base I just mentioned. So here's my base e, real big. Now the rest of it is going to switch sides. So the y minus 7 will end up out here, and the x minus 3 is going to end up over here as the power. All that's left is to get y by itself, so add 7 to both sides. This is going to give you your final answer, but I will go ahead and put the h back in. So h inverse, with a little negative 1 sign for inverse, is equal to e to the x minus 3 power plus 7. Okay, number 11. Alright, almost the same thing. Okay, this is the same thing as y equals, so when I switch x and y, I will have x equals log y minus 4. Trying to get y by itself, the first thing you're going to do is add 4 to both sides. So then you have x plus 4 is equal to log y. How do I get the y out of there? Well, it's time to rewrite this in exponential form. Once again, please understand there's an invisible base here. This time it's 10. And we have to start with that invisible base. Okay, so I've got base 10. Now, the x plus 4 and the y are going to trade sides. So on the left, I'll have y equals. The x plus 4 is going to become the power. And that is the final answer, except for I will write p inverse is equal to 10 to the x plus 4 power. All right, that is number 11. Number 12, find the value of x in this equation. All right, there's a lot of different ways to do it, but I would recommend rewriting this in exponent form, starting with the base. Okay, so the base is x, so that means I have x first. Now these two things are going to switch sides. Okay, so I'm going to have x. Now this negative 2 is going to come over here and become the exponent. And over here I've got my 81. Okay, now the easiest way to get rid of this negative 2 is to multiply by the reciprocal. So if I do times negative 1/2, everything cancels out and I'm just going to get x. But in the meantime, I have to also do the negative 1/2 power over here, because really that's what I'm really doing, is I'm raising both sides of the equation to the negative 1/2 power. But as I said, on the left, these completely cancel out. The 2's cancel out, and a negative times a negative is a positive, so that just leaves x. Now over here, a negative exponent drops you down to the denominator. So this would be 1 over 81 to the 1/2 power. Now I'm hoping you remember that the 1/2 power is the same thing as square root. So that would be like having 1 over the square root of 81. Feel free to skip that step. Square root of 81 is 9. So the final answer would be 1/9. Okay, so that's it. Number 13. What's the numerical value of this? Well, first of all, look, 0.1 is the same thing as 1/10. Okay, so what I really have here is log base 1/10 of 1,000. Alright, so I've taught you many ways to do this, but basically you're asking yourself, okay, 1/10 to the what power is going to give me 1,000. Alright, this is what you're thinking in your mind. And one way I've taught you to do this was to, for a moment anyway, disregard the 1. Pretend like it's not there. Deal with the 10, okay? 10 to the what power is equal to 1,000? Well, count the zeros. This is 10 to the 3rd power. So that would mean the value would be 3. So at first you're thinking 3. But then, since it's really 1 over 10, then that means it really would take a negative 3, because the negative power would make this the reciprocal, and then it would be back to 1,000 again. Alright, so the final answer is negative 3. That's probably the easiest way to do this problem. Okay, which of these is not correct? Well, when you're condensing, addition turns into multiplication. So this would be like having log base 3 of 5 times 10, which is 50. So that one's okay. We're looking for the one that's not correct. Again, when you are condensing, addition will become multiplication. So this will be like log base 3 of 4 times 13. that is definitely not going to be 17. Okay, this problem is adding 4 plus 13, and that is wrong. So B is the one that is wrong. That means B must be the correct answer. Okay, the rest of these make sense. I'm going to run through them real quick. If I condense this, subtraction becomes division. So this would be log base 3 of 12 over 4. Okay, and well, that's log base 3 of 3. 3 to the 1 power is 3. So that does equal 1, which is true. And looking at D, well, anything minus itself, this side of the equation is just 0, right? Meanwhile, over here, 3 to the what power gives you 1? Well, that's the 0 power. Anything to the 0 power is 1. So both of these sides have a value of 0, so that's another true statement. In this last one, we know that we could take that 4 and put it as a power instead. But then 5 to the 4th power turns out to be 625. So that is also correct. Okay. Alright, number 15. Condense this expression. Well, if we're going to condense, let's take this coefficient and put it back over as a power. Like that. Okay. So then subtraction turns into division. So I'm going to have log base 3 of 10 over x to the 10th power. And that's it. That's all there is to that. That's condensed. Alright, this one we have to expand. There's two key things. First of all, understand that this is the same thing as y to the 1/2 power. Second, understand that we are dealing with three things. This, and this. Treat them all separately. So these three factors, I'm going to have three terms, all three different log terms. Alright, so I'm going to have log base 3 of 27, and I'm going to have log base 3 of y to the 1/2 power, and I will have log base 3 of x to the 3rd power. Now, anything that was in the numerator is going to become a positive term. So this is positive and this is positive. Anything that was in the denominator is going to be a negative term. For the final answer, we need to put any exponents in the front. And log base 3 of 3 has a whole number value. 3 to the 3rd power is 27. So this will just be 3. So it'll be 3 plus 1/2 log base 3 of y. Okay, again, we're just putting these in front. So that'll be 3 times log base 3 of x. So this should be your final answer for number 16. Okay, and I think that is the final answer for this problem. It's the final problem on this worksheet. Alright, I hope this was helpful. Make sure you watch the second video for the rest of the review. And I will see you on that next video.